Let's explore how to find the mean and standard deviation under the central limit theorem for means. Now recall, the central limit theorem tells us that when given certain conditions, the mean of a sufficiently large sample of data will approximately follow the normal distribution. And this is true no matter what the distribution of the original population was. This is very important because when viewing a set of data as a normal distribution, it's much easier to work with. The central limit theorem has two forms, the CLT for means and the CLT for sums. Here, we're going to focus on the CLT for means. The CLT for means tells us that if you keep drawing larger and larger samples and calculate their means, the sample means will form their own normal distribution. For instance, if you're rolling dice and you take the mean of each set of dice you roll, the more you roll, the closer the sample means will be to a normal distribution. Interesting. So this theorem affects two parameters of the original distribution, the mean and the standard deviation. Let's explore these effects. So the mean of the new normal distribution is actually equal to the mean of the original distribution. This is denoted by mu sub x. On the other hand, the standard deviation of the new normal distribution is equal to the original standard deviation divided by the square root of the sample size. This is denoted here, telling us the new standard deviation is equal to the standard deviation of the original distribution divided by the square root of the sample size. As the sample size n increases, the distribution of x resembles a normal distribution. So, we're able to say that x resembles a normal distribution, which is a function of a mean and our new standard deviation. Let's look at an example. So an unknown distribution is created from a reported set of data. The distribution has a mean of 60 and a standard deviation of 12. A sample with size n equals 16 was selected from a population. Using the CLT for means, what is the mean and standard deviation for the sample mean distribution? Well, we recall that the mean of the new distribution is equal to the mean of the original distribution. And in the problem, we're told that the original distribution has a mean of 60. So, our new mean, mu sub x, is equal to 60. Also remember that the standard deviation of the new normal distribution is equal to the original standard deviation divided by the square root of our sample size, n. Again, in the problem, we're told that our standard deviation is equal to 12. So, using the formula, our new standard deviation is equal to 12 divided by the square root of 16. Or, when simplifying, our new standard deviation is equal to 3. So, when given an unknown distribution with a mean, a standard deviation, and a sample size, under the central limit theorem, we were able to find the mean and the standard deviation for the sample mean distribution. In this case, the new mean was equal to 60, and the new standard deviation was equal to 3. Our new distribution then reads x is similar to a normal distribution, which is a function of 60 and 3.